Okay, thank you. This is going to be a bit difficult to fit in the shortened time, so I'm probably going to be kind of stressed and have to run through this. The history of RCA and the RCA station in Bolinas has probably got to be one of the most convoluted and complex stories, maybe only superseded by the Old Testament of the Bible. So to pack 10 pounds of this in a 5-pound bag and then find out it only holds 3 pounds is going to be rough. So let me see what I can do.
You got to put the lavalier on here. Sorry.
Yep.
Okay.
Okay, let's see if the pictures work. This is all pictures, so with no pictures, it's tough. Okay, first one. Okay, so these are the guys that invented radio, all lined up together for a dinner of the Institute of Radio Engineers. Tesla is in the background somewhere there, along with Alexanderson, and a lot of these people are going to be part of this story. Okay, the next one. This is a gathering again at the experimental radio transmission facility in New Brunswick, New Jersey, which served as the experimental prototype for the Bolinas, California station. This is after it received its Alexanderson equipment, and Steinmetz, the brain that conceived all of it, is standing there, the little guy in the middle. And the guy that invented and designed the mechanics and all the thing doesn't seem to want to be in the picture. Alexanderson's hiding in the back. And David Sarnoff is making a particular point of jutting over and getting himself in the picture. So it starts to display the personalities that we're dealing with here. So next. So we start with Nikola Tesla, the guy that conceived the whole process of transmitting electricity from point A to B without any wires. An essential feature for electric radio. This is his basic system that he conceived. He came up with a set of patents and lectures and notes and other things that in his time made him quite famous. His displays of transmitting electricity across New York and what have you were pretty well established. It wasn't enough to run any big motors, but it was far better than what was needed for radio. But there's no way that anybody could gain a patent on any type of radio system as the way Tesla's patents were set up, but somehow things took a big shift, and Tesla failed to execute his system. There's all theories around of why this happened, that Morgan put him out of business, that he didn't really know how to make anything work. My analysis is Tesla was a victim of his own poetry. And then that was seized upon, and his system was swept under the carpet. The era this happened would be about 1900. So Marconi slips in where Tesla lives off and tries to figure out a way to gain this transmission ability and circumvent all the Tesla patents, which was nearly impossible. This was his system, based on the Hertzian design of his college professor, a guy named Rigi, that did a lot of primordial microwave work using spherical spark gaps in oil. You have to remember, in this day there was no tube or transistor or any of that type of convenience. If you had to transmit from a broadcast transmitter to a radio receiver, the radio receiver had to pick up enough electricity from the broadcast transmitter in order to operate itself. Unlike today, where you have amplifiers and other type of devices that draw power off the battery or the power company and produce the signal. So we're dealing with a different type of technology here. So Marconi basically adulterated the Tesla system and somehow thwarted the patent system, and it just started this all-out crackpot reality in radio that existed for about 10 years. Then finally, the next person, Alexanderson, started with the work of Fessenden and produced a type of radio generation system that actually did work. It was engineerable, math was all together for it, and it didn't interfere with anybody's patents. So these are the 3 stages of engineering implementation that you would find occurring out in Bolinas. Even though there's many more that occur after this, all the way up to my own work out there, we have to focus on the important part and not the stuff that uses well understood or accepted technology. Okay, next. These are some of Alex Anderson's patents. His so-called alternator, and then next his antenna system, which is one of the most important research areas in electrical engineering that I consider to exist, is the Alex Anderson antenna. It does things that no other antenna can do. In fact, it's not even really an antenna. It transmits in another dimension, to use the phrase of physics. And that's kind of my main focus on the Bolinas side and my research. Okay, so to begin the story, let's see who the people are that are going to tell it. Okay, well, so about this guy, Sarnoff, the guy that screwed everything up. This is a picture of David Sarnoff when he first went to work for Marconi. And he became the nemesis of all of these other workers and inventors of television like Farnsworth and the inventors of FM. And he was the king of RCA, became the president of RCA until he died, and then the company died with him. Okay, so let's keep going. So those are the 4 players. So this guy, how we're going to approach the disasters from the standpoint of the Navy, because basically the Bolinas site was considered an important naval asset, and technically still is, because the Coast Guard operates part of it as Station NMC. Okay, so now this is where I pick it up in my book here. So this is Admiral Nimitz, and he is providing an introduction to a very interesting history book that was written by, we have that page next? Mr. Howarth. Just ran across this recently. And the Navy plays the center role in the entire history of electronics and radio and all the things that were going on between the turn of the century and World War II. So Admiral Nimitz points out here in his introduction, we go to the next one, there's certain things that he makes reference to. You go to the next page. Was that the next one?
That was the next one.
Okay. So, of course, he points out how the Navy is a leader in scientific traditions and experimentations, which is absolutely correct. And the following documentary, Mr. Howarth's book, supports the drive and encouragement for scientific research. And then, again, he claims the Navy led the world leadership in electronics and the urgent need for better equipment. And then he points out the situation around the vacuum tube, which is the center of the whole story of radio, is the vacuum tube. Originally, a vacuum tube had a life of some 70 hours and cost $50 each. Limitations which made their widespread use economically unfeasible. However, shortly after World War I, the Navy solicited bids on a 5,000-hour tube costing no more than $5. The successful bidder met these revolutionary specifications, and in doing so, the Navy had sired a major contribution to the wildfire growth of commercial radio in this country. He points out it's a giant step from the spark gap transmitter of a half a century ago to the transistorized multiplex of today. And then he says, yet we merely stand at the threshold of a new and exciting science. But where is the new and exciting science? It's still the same old technology, just in a different package. So as far as the Navy follows in this, let's go to the next picture. The Navy had some real serious problems in trying to keep radio going on their ships. Okay, the next. So the
Here's the laser pointer.
yeah, I might need that. Okay. So this is Assistant Secretary of the Navy, Franklin Delano Roosevelt. And he has a situation on his hands, which is this following letter. Okay, which unfortunately the highlighter has blocked it out like an FBI style for us, but that's what the computer does for you. At any rate, he's instructing this judge to deal with the fact that the Navy is in the middle of a patent suit because the radio they bought from one guy and the radio they bought from the other guy, the two guys are fighting, and now the Navy's in the middle of it. And none of this stuff's working. It's all problematic. and everybody's trying to rip them off. So this is basically the state of radio history that the Bolinas station is spawned in. Okay, I'll go to the next page. So here we have one of the big shots of Bell Telephone Laboratories that considers the whole thing a joke. This is Mr. Espenscheid. He's writing a letter to Hard and Pratt, the guy that built the station for Marconi and Bolinas in its first conception. And this is his idea of the whole, what he called stock jobbing. And these are all the so-called inventors of radio and all their little financial wheelings and dealings and rip-offs, and nobody produced much of anything that works. So we'll go to the next page. So he's writing a letter here, and
I can read it.
Can you? Can you read it? Can you read it out for me?
Also of the Machiavellian Franklin D.R. and his favoring of government ownership of wireless. So that was the...
So what's going on here is Assistant Secretary of the Navy Franklin Delano Roosevelt wants government to completely take over all radio. And it became shortly afterwards that it was illegal to own any type of radio equipment or antennas or even have it standing. And all ships had to take their stuff apart before they came within a certain number of miles of the coast. So Mr. Espenscheid regarded him as a Machiavellian politician, and him and Sarnoff are figuring on creating this international government ownership deal, and then he concludes in that thing of some kind of trend towards worldwide collectivism. Then he has like some other comments about, okay, the Bolinas station was part of what was called the imperial chain, which was all these super high-power disruptive discharge transmitting stations that were supposed to ring the world and carry Marconigrams in a loop all the way around the world. The whole thing was a big engineering failure, expensive, and it didn't last long. So these guys are joking to each other about it. This is kind of like the private correspondence between these two, actually now very famous electrical engineers. Okay, the next one is, this is kind of how he regarded Roosevelt. There's a picture of Roosevelt and the definition of the word Machiavellian. So Roosevelt had a lot to do, like Sarnoff, with directing radio history in ways that its inventors really weren't happy about. Okay, let's see what his next letter is. Okay, can you read that?
Yeah. Thank you for the little dissertation on the Marconi mammoth spark stations of the old imperial chain. The Marconi engineers did stretch their spark technique to the limit, if not beyond the elastic limit. I remember the transmitter at Kahuka, Hawaii, when there in 1915. All that summer, it had one hell of a time trying to communicate with Bolinas, California. Further down it says, they could not make Japan. And then further, have been total failure and have never been able to work across the Atlantic.
So the whole thing was kind of a big joke.
Atlantic rather than Pacific?
What's that?
Atlantic.
And the Atlantic. Well, New Brunswick was the Atlantic station and Bolinas was the Pacific station. And the stuff just simply wasn't working. And then about this time, Tesla wrote several public articles in which he was laughing at these people and said the government would have to take control. And that's actually what it went about to do, was to gain control. And unfortunately, being that we're low on time, I can't really get into a lot of the Navy material where they created RCA. But I'll start with that part and just kind of deal with the situation. Okay, so we have the title in the book here is Navy and the Radio Corporation of America. So everybody's heard of the Radio Corporation of America, or RCA. But what was RCA and how did it come about? So it basically started that Marconi wants to strengthen the British domination. The political situation is the oil and the transportation and the communications and all of the stations that the Navy and everybody are using were either built by foreigners or crooks. So it became a real problem, engineering problem, because there was no engineering formulas or equations. Everybody's patent was ripping everybody else's patents off, and they were all a way to get around Tesla. So we can go look at some of those diagrams, I think, here up ahead. So that what the Navy ended up was with these, what you would call Rube Goldberg machines for radio transmitters that had to leave out all the key things that were in the Tesla patents. So they had the Marconi system. Now what Marconi tried to do was repeatedly rip the Navy off and force them to buy stuff that they didn't want and go through foolish tests and then not own the equipment and have to hire, the Navy would have to hire their operators on as civilian personnel, and the whole thing the Navy just said, we're not interested. So what happens is Alex Anderson now is perfecting this alternator into the new revolutionary high-frequency power source that's going to make voice and music possible, the big dream on radio. This is what everybody's been waiting for. So as soon as the war situation starts, Alex Anderson and Steinmetz are experimenting with this thing in the New Brunswick station, and Marconi is all lit up because it's his station, and this is going to be the new thing, and he wants GE to sign the whole deal over to him, and he's going to monopolize it all around the world. And that really got the political situation all broiled up. Because at that point, the British were not the friends of the United States, not at that period of time. So the Navy opposes the whole thing. They don't want Marconi getting anything. So GE, they decide, well, okay, well, we built this thing, now who's going to buy it? So they get together and they conceive this American-controlled radio company, which they call the Radio Corporation. It wasn't like, you know, the International Telephone and Telegraph or, you know, Pacific Gas and Electric. This was the Radio Corporation. And it was to be a conglomerate that was supposed to take all this scattered vacuum tube, patent fighting, and all this type of stuff and merge it all together so that all the major corporations and even the little guys could start to produce this stuff and develop the art without it being all stifled in these longest in history patent suits between DeForest and Armstrong and Marconi and Tesla. And this whole thing was just out of control and nothing worked, and it was owned by foreigners. And, you know, and half the people that built the stuff on the ships were going to jail. So RCA was born in order to alleviate this situation. So I think I'm going to have to depart from the Navy now and get right into the actual, we can go through some pictures of their equipment here. So this is what they got from Fessenden. Fessenden was the inventor that encouraged Steinmetz and Alex Anderson to come up with the alternator that made the actual continuous wave and amplitude modulation and the radio modes that now are well established possible. It was never possible before with any disruptive discharge because of the noise of the sparks, and you just could never get a clean signal. So Fessenden, but most of Fesseden's stuff didn't work, and he was hard to deal with. Okay, then we have DeForest. Okay, DeForest's stuff tend to work a little better, but then the thing is he always was dragging patent suits along with him. So if you had his equipment, you had his patent suits. And all these things from the standpoint of a modern day radio or a Tesla type radio are all Rube Goldberg machines. But there's some interesting theoretical stuff to study in them. Okay, the next one. Okay, this is the Stone system. The Stone system used like ceramic sewer pipes with wires in them buried in the ground. It was, and it was highly classified at the time. It was a type of through-the-earth communication system. So you see the antenna on this is portrayed a little differently as this kind of multi-wire structure, and it was usually undergrounded. You see, things are all real primitive, like, you know, you got a battery and a telephone bell, and then these things here are just like, you know, little coils that you move back and forth. This stuff's all is primitive. You could, you know, make it out of garbage cans and things you found in the dump. Nothing high-tech here. But nobody understood what kind of waves was traveling through this stuff because there was no way to mathematically. That's what I got into in my last talk. So this stuff was generating frequencies and waves that no one had a clue. And it happened to be if one thing hit off on another thing, then you had a new technology. But as soon as like one wire was changed or something, then all of a sudden none of it would communicate. So this is what they're up against. There was no frequencies or wavelengths. It was all just these things that if you fooled with them, they'd, you know, like we used to do when we were in grammar school. Okay, next. That is Massey. Okay, you never even hear of him. He was a big radio guy at the time, made a lot of stations. So they built all these coast stations, and then after they were built, and everybody bought all the stock and everything for the corporation that went with the station, then you come there Monday morning and it was abandoned. So that's how these wireless stations were going up, and they were just being dropped. So this is the radio situation that existed from 1900 when Tesla got pushed out of the deal until 1919 when the Navy started RCA and pulled the whole thing back together again. Somebody, you wanted a question? Yeah.
Oh, so on the one with the alternator, how high a frequency could you?
Well, the little ones were 200 kilocycles, and the big ones were like 20 kilocycles. So they're not real high frequency. But it depends on what you put that frequency into. So now we'll focus more on the Bolinas situation. So let me go to there.
There's also the radio equipment.
What's that?
The radio equipment.
Oh, this is what the Navy ended up with. This is all the equipment they had at the time when the trouble broke out. So you can see each company, a lot of stuff was from Germany. Telefunken and the Atlantic Communications Company made most of the functioning radio equipment. The Marconi stuff and other stuff didn't really, that was part of the problem for the American government, is the Germans were the only one that were making anything that worked. They continued to utilize Tesla's concepts throughout their designs because it wasn't banned in Germany like it was in America to talk or think about such things. Okay, just keep going through that. Okay, this is the Bolinas site as it looked in about 1928 to 1930. So that was the vacuum tube transmitter building. And you can see the antennas. Some of them are still the old Marconi Alexanderson. Some are the new Alexanderson type A's. Some of them are the Beveridge type B's. It's a whole array of antennas out there. It could be a talk in itself. Okay, this is next. That's the receiving station going up in Marshall. And then that's the Marconi building. So let me just point out some things here about this. So what we're mainly interested in studying the Bolinas station is not so much about electromagnetic radio, but this primordial electrostatic wireless that existed before it. It was a radio that wasn't electronic radio, but it was electrical radio. And the electrical system of the antenna could interact through the transformers and motor generator sets with the electrical system of the utility company, where an electronic radio system can't possibly do such a thing. No power can flow backwards from the antenna into the power lines from the power company. So right there you have a different situation. And then the waveforms produced by the electrical radio are not necessarily sinusoidal, but they're complex harmonic or they're disruptive transients, and the propagation of those waves has never been studied. So the key thing with the electrical radio was, being there was no electronics and no amplifiers, is the transmitter had to transmit enough electricity to the receiver for the receiver to be able to operate its own detection. In other words, the receiving element was a spark gap as well as the transmitting element. So if you couldn't get a spark to jump inside the little glass tube of shavings at the receiving end, then you weren't going to get any detection. It was basically high voltage at both ends. So it was kind of a half-baked Tesla power transmission system that transmitted just enough power to get the receiver, so-called detector, to operate. So this period existed in Bolinas about 10 years. It started with Marconi in 1913 when he built the site. Alexanderson got there in 1919, and that went on until 1924. And then when they found, after they spent untold millions of dollars on the giant Alexanderson system and all the research, Armstrong came up with the oscillating vacuum tube and detectors, and then obsoleted the whole thing as soon as it was done. So that was the end of it, except for one purpose, the Navy's purpose. The Navy's purpose for that is to communicate with submarines, because Marconi and Alexanderson system never transmitted through the air, and their structures are not really antennas, they're transmission lines. The transmission all occurs through the inside of the Earth. It's not an outside of the Earth problem, but nobody ever realized the full potential of this whole system back then. So even though the alternators were considered an obsolete source of alternating current power with their vacuum tube replacement, the antennas was still capable of doing a lot of very interesting things. So the Navy took an interest again in 1940 and cobbed the whole thing back together and moved part of it to Hawaii so they could communicate with submarines, and it was kind of a secret situation. It never really involved the full Alexanderson principle. It was jury-rigged the whole way. So it's not much for scientific study. And then, of course, in the American tradition, after they were done with it, they destroyed everything. So a new shortwave system appeared in Bolinas to replace it. That's the point at which the technology where I was involved with the station. And that system became obsolete, and it was destined to go the same way. It was supposed to be smashed. But I had intervened along with some other forces, and we stopped that from happening and directed into a research situation. The problem was the satellites were putting the HF out of business, and so it was time for somebody to come up with something new. So the plan was, in my mind at that time, was to go back to the Tesla system and make it work and be able to communicate with the ships at sea without using electromagnetic waves and having all the attenuation and noise and all the problems that go with it. But various forces appeared and made sure that that wouldn't happen, and all of the equipment was destroyed repeatedly. So when Marconi built this thing there that didn't really work, and then the Navy kicked him out and took it over and formed RCA. They brought Alexanderson out there, and they brought him to the New Brunswick site, and this is where he was going to build his new fantastic radio communication system. The Alexanderson system's a little unique because it doesn't really transmit electromagnetic waves, and it transmits through the inside of the Earth. So the wave propagation and the attenuation of it is not going to be what you find in normal textbooks. So the Marconi antenna initially was 3,000 feet long, 600 feet wide. Let's see what more pictures we have of the antenna field. These are the newer short-wave ones that went up after the Alexander system was obsoleted with the vacuum tube transmitters. This is all in Bolinas now. You can see the two buildings there, the original Marconi mass, and just acres and acres and acres of poles and wire, untold, like 3,000 acres of it. It goes on for miles and miles, or did in every direction. So the basic the Alexanderson at Marconi was 3,000 feet in length, 600 feet wide, and 300 feet off the ground. Okay, its electric field, which can be estimated to be about 120 million cubic feet, had a stored energy of 20 million volt amperes. The coils that regulated it were 12 feet high. This thing was like a massive substation of sorts. The whole antenna would light up at night when the telegraph key was put down like a giant neon sign. That's how much electrical activity was going on with it. The voltage is estimated to be about 100 kilovolts. So even though we had this giant thing out there roaring away and glowing in the dark and all this naval stuff, it's all of a sudden we don't seem to know anything about it. It just seemed to go away. But it started to come back out again through some roundabout radio research, and then some interesting things were discovered about it. So in 1913, that's when Marconi decided to put this thing together out there. Let's go through them. So this is exactly where it's at, geophysically. Now the thing about this place is it's rather unusual. You can take an older Army type of field radio set, the one that has the coils in it, the older technology, and put a battery clip on the antenna terminal and go around town and connect this thing to fire hydrants, and all of a sudden signals are booming in from all over the place. So Bolinas is a strange convergence. You have the, does this work? It's going to do the same thing. Well, you got to hold it down. Okay. So the San Andreas comes right up here, okay, and goes right out this hole, basically. The San Gregorio starts in here, and it goes out. And then there's another one that comes out here and goes out to sea. So this whole place is like a convergence of all of this seismic activity, and it has this type of water that has this rich colloidal iron in it. It turns your toilet bowls red. It turns the leaves of your plants red. The place is like some kind of magnetic anomaly. So this, in all probability, is why Marconi built this thing here. There's no radio reception like it anywhere I've been, anywhere around. This place is just lit up with RF. And it's such a tweak to the place, basically ether-wise, that even before any of these people built anything there, the Indians used to go there and get this, they get charged out there, and that they stayed too long and start to make them goofy. So they tend to avoid the place except for special charging intervals. This was like 3,000 years back. So there is a possibility that some of these bizarre antenna structures could have transmitted back in time as well as forwards in time and polarized the area and created an electrical charge situation there, because there can be no before or after situation like that. And this is what electricity, as I showed in my last talk, none of these things are unthinkable in the dimensions of electricity. This Alexander's antenna has all the possibility, if that was developed a little further, that if there was one in New York and one in San Francisco, and everything was tuned right, if you're standing in the one under the one in San Francisco, when everything's energized, you'd be standing under the one in New York at the same time. This is as you would consider the new type of radio, rather than fooling around with the old type of radio, where you have to shove all this electricity and scatter it halfway through the universe just to get 1 picowatt of it at the other end of the line. But this is what Tesla was working on. And Alexanderson and all these people had to, reenact certain parts of Tesla's ideas in order to make stuff work. So let's go further down the line. Okay, this is what's left of the antenna field today. It's basically, even though there's supposed to be a historic society there, it's a fraud. The purpose of the Historic Society is to prevent this possibly from becoming a naval asset again. It's just a front for a communist or some kind of foreign organization. It's a kind of a strange collusion of people out there that block its use and continue to destroy it. But that's a whole other topic of discussion. Okay, there's what's left of the Marconi building. They vandalized all the stuff inside. So it's pretty much gone. Okay, there's another shot. There's the coil shack. Is the fricos of the town managed to put an illegal FM radio transmitter up there, so that kind of shorted out the last of the Marconi antennas, so you can't use that anymore. I don't know exactly how these people can get away doing it, but there's no law in their world. They can just do whatever they want. Okay, let's keep going. This is one of the Alexanderson coil mounts. It's about 7 or 8 feet across. There's a giant underground network of wires that comes up into that thing for grounding, and I have them all tied together there, as you can see, with the copper wires, because I was using that as a transmission point for a Tesla transformer, because it's a massive, very low impedance ground system. Okay, let's keep going. Okay, that's the Marconi building again. I had my laboratory in there for some time, and then all of my research materials come out of this site for a period of about 20 or 30 years until eventually it was just squelched out of existence. Okay, let's keep going. That's the ocean. Okay, the ground cables from the underground, there's an underground antenna underneath this Marconi building, about 750,000 square feet. It's all still intact there. You can still connect to it. I put in little manholes with terminals, so I can still go out there and connect. What's gone now is there was a whole radial ground wire system that went out here into the ocean, and there were large metal plates bolted to the rocks out in sea. So the grounding of the station is beyond any imagination of just, what you would consider with a couple of ground rods. This thing was giant. It had to transmit 2,000 or 3,000 amps of current flow through this structure into the ground without any backup or fires. Unfortunately, the diagram that I had for that has disappeared, and we couldn't get it. It's what we would consider a radionic structure. It kind of keeps the place energized in the voodoo level just because of its geometry and the intensity of it being there. But that's kind of out of the topic. Okay, let's keep going. Okay, so this is the stuff that Marconi started to build in there. So you can see the main switchboard kind of up on the top there. The switchboards back then were made out of marble because there was no plastic or composition material. The voltages there are about 2,400. The hot stuff's in the back for the 2,400. The 480 is all hot in the front. Then that ran these large motor generator sets that took the 60 cycles and converted to 210 cycles, and then there was a big spark gap on the other side that discharged this enormous bank of capacitors into various transformers and coils to run this 3,000-foot long antenna. Okay, let's keep, to give you an idea of the ground system. This is not the Bolinas one's much more exotic than this, but this kind of serves to illustrate the magnitude. That big building, RCA building, would be this right in here. So this gives you an idea of the enormity of the ground system that surrounds these kind of power plants. And then out that whole 3,000 feet, you have ground wires going out to the end, and then you have like one cable that takes it down into the ground plates into the ocean. So this thing is like a geoelectric treasure for scientific research, but nobody's allowed to touch it. Okay, let's keep going. Okay, these are the 210 cycles stepped up to about 12,000 volts and charges these capacitors, which is blasted into this giant coil. This is about like 8 or 10 feet high. You can see how thick the wires are. This is the power flow in this thing is beyond calculation. And then there's various impedance matching coils in the back. Okay, keep going. This is the plan of it. These are the copper sheets that connect it to the capacitor bank. It's like a parallel strip line. You've got a bank of capacitors here and a bank of capacitors here maybe, or I don't have the diagram. And then that all discharges into this big inductance of little tiny wires all specially woven to keep the magnetic fields even. It's called Litz wire. And then this converts that into a voltage, which is then fed into other coils, which I think we can see in another picture. Next picture. Yeah, there's another shot of the big one. These are the blowers for the spark gap to blow the air out. Okay, keep going. This is a little one like they would use on a ship. So this is something that Marconi stole from Tesla, called the oscillation transformer. But normally, back then, you were supposed to call it a Tesla coil or a Tesla transformer. So the word started to get changed here. Okay, keep going. That's some of Marconi's first experiments. Keep going. Okay, these are like his first radio setups. So the thing to note here is that there's no tuning. That all you got is you just have a plate in the air and a ground and a spark in between. So there is no frequency with these things that you could call frequency in the normal sense. You couldn't tune them. So if one operated, then you couldn't operate any other radios because they were all transmitting into each other. The receiver was the same thing, and then there was a little spark gap in here of nickel chips that was kept turning. And they would weld together when the energy would come across the system and then ring a bell, and that would usually actuate the telegraph center. This was the original experiment that his college professor had built to generate his microwaves, and then he just kept adapting it. This Tesla was so far beyond this that this is basically a joke. This is what people do now when they're like 12 years old, if they do anything. Okay, that's next. This is Tesla's idea for his transmission system through the Earth. That's the patent. Okay, that would transmit power as well as signal. Okay, keep going. This is one of Marconi's attempts to get around that patent, was to use coax instead of helical coils. And I tested it with open wire transmission lines, and it will transmit through the ground. It does work. Okay, keep going. This is his UHF and microwave experiments, which made things take a big historic twist later. This was the original Heinrich Hertz apparatus that Marconi copied from. So this was the original experiment where electricity was made to go across the room and appear at a receiving end. That was a big thing back then, was to have a spark at a transmitter, and the spark at the other end of the room at the same time was like the UFOs showing up. Okay, keep going. Okay, these are some of the guys again. Okay, keep going. This is Tesla's, one of Tesla's spark gap. See, all this stuff later, Fessenden and DeForest and Marconi and all of them just figured out ways to change it around and repatent it. But all the stuff that Tesla came up with is all so fundamental that there's no way that anyone should legitimately have been able to make money out of radio without paying him royalties. Okay, keep going. This was Tesla's final project, where all of a sudden he kind of went poetic and drifted out of the situation, and funding disappeared, and then he was made to look like a bad guy, and that was the end of that, about 1903. And that's when all this other DeForest and Marconi and all this stuff got started, and just freeloading on Tesla and taking advantage of the glom, but not making anything that can work. Okay, keep going. Okay, now the same thing happened with electricity. You had Tesla and you had Edison, and they didn't like each other's system. And they fought, just like the people in the radio did. So the electrical industry kind of started off with the same thing. So you had the DC system of Edison, and you had the AC system of Westinghouse. So needless to say, the Westinghouse system was the Tesla system. So Edison would electrocute circus animals in public and hire kids to round up stray dogs and cats and then fry them with alternating current generators to show people the horrors of this. So what Tesla did is he lit himself up with so much RF on stage, and no one knew what RF was back then, that sparks would jump off of his hands and he'd make wires explode between his hands. And finally, at the end of the thing, he got his whole body to light up like an electrode in a neon bulb on stage. Turned it off and there wasn't a mark on him. So I guess AC wasn't that dangerous. So what J.P. Morgan did is grab the leash and gave it a yank and took all these people's business away and formed General Electric. So General Electric is the womb of RCA. So it's kind of good to know a little bit about General Electric before you get in the RCA. Okay, let me get to that point here. So okay, keep going next. Okay, and then we have David Sarnoff. Okay, now David Sarnoff came to work for Marconi as a boy, and then the two became like buddies. So Sarnoff was the protege of Marconi and liked the way Marconi did business and continued to do business the way that Marconi did it, much to the upsetment of everybody else, particularly the Navy. Okay, keep going. These are the two guys standing in front of some of the equipment that they used out there in Bolinas in the vacuum tube era. This is Marconi and Sarnoff in their later years. Okay, there's David Sarnoff again. So when RCA was formed and absorbed up American Marconi, then Sarnoff was in a position now to form this new corporation. But then he just started on a rampage of putting everybody out of business and monopolizing the vacuum tube industry and causing problems with just about everybody he came in contact with. And then eventually he took the company over. And when Marconi was kicked out of Bolinas, the Navy put RCA in there. So from henceforth, after the formation of RCA, the Bolinas site was RCA and no longer Marconi's. It was part of what we call the Radio Corporation Communications Incorporated. Okay, we keep going again. Okay, now this was one of Farnsworth's biggest enemies, was Farnsworth.
You mean Sarnoff's biggest enemies was Farnsworth?
What's that?
I mean one of
Sarnoff's biggest enemies was Farnsworth. So Alexanderson and GE and RCA and all of them had worked for decades and spent millions of dollars on trying to create mechanical television, which didn't work. So Farnsworth, when he was in high school, came up with some idea how to do it electronically. And then continued to experiment and studied the whole art of electron emission and optics until he became a master at it and produced a completely functional electronic television system in 1928. Sarnoff didn't like that at all. Television was going to be for RCA. He was incensed. So they attacked this guy severely. He's the only guy that's ever won in court against Sarnoff. Sarnoff's lawyers actually broke down in tears in the courtroom, but Sarnoff managed to get the FCC to change all the frequencies around in the whole thing and keep him out of business until his patents expired. Okay, let's go to the next one. Here's the guy that Sarnoff had to steal all of Farnsworth's designs. This guy was allowed into Farnsworth's laboratory as a Westinghouse engineer, but he was really with RCA, and then he glommed up all of Farnsworth's principles and stole them for RCA, and then he kind of worked them all around to try to fight the patents. So now you had a big patent war going on between two TV guys. Okay, let's keep going. So this is the first Farnsworth camera tube. It was so simple that there's basically nothing there. It was a revolution how such a simple device could take a television picture and convert it into an electronic signal of some kind. Okay, keep going. So this is Armstrong. He's the guy that invented the basic radio tube circuits that put Alexanderson and Marconi and all of that large VLF stuff out of business. He was a little bit on the crazy side. That's him standing on top of the RCA tower. At that time, he was Sarnoff's buddy because RCA was buying up Armstrong's patents, which were revolutionizing the basic radio receiver construction and design and performance, orders of magnitude beyond anything that had previously existed. It was a whole different world. When he came up with his circuits, then radio was flying. There was you didn't have the need to send electricity to the receiver anymore. You could do it all with amplifiers. So Sarnoff retained him for a while until he developed FM, and then Sarnoff threw him out, and then they spent millions and millions of dollars fighting each other. Let's keep going with that. So here he is with Marconi. That's the original, where he gave the original demonstration, that building there, of his radio tube detector that everyone was looking for. Okay, keep going. And then finally, the endless lawsuits, he kills himself. So that was the end of that. So Sarnoff basically drove him into the grave. So let's keep going. Okay, now we come to the Alexanderson Navy situation. Okay, so after all RCA was formed and all this stuff, this came about. As you can see, Marconi's not looking very happy in this picture. He's just been told that he's not going to get any of Alexanderson's equipment. And there's Alexanderson standing next to him. Marconi got the big choke right here. He is not happy. Okay, let's keep going. So this is his system. You can see the basic principles of the generator. There's really no other electrical generator like it. And it cannot be expected to behave in any way along the lines of the law of conservation of energy. You can take all the law of conservation of energy and throw it away with these kind of machines, because there's no direct relationship between the kilowatt hours in the shaft and the kilowatt hours in the output transformer. So it's not really a generator. So what you got here is you have a set of magnetizing windings that energize this magnetic circuit. Okay, and then you have these pickup coils, okay, that are in a smaller high-frequency portion of the magnetic circuit. So the pickup coils go to the output transformer, okay, and then the magnetizing coils go to the battery. The key's not really there. Somebody that drew this didn't know what they were doing. Now, in the middle of this thing spins this big disc, okay, and this disc has alternate segments of magnetic and non-magnetic material, so that this magnetic loop here and the coils are connected together and taken apart magnetically at a very rapid rate. It's kind of like a magnetic, I would call it a magnetic modulator. And it has to be done in such a way that the average magnetic intensity in the excitement to have this technology to speak to people over there without it being able to be jammed out, and actually in voice rather than some kind of code that most people don't understand. So it was the big thing at the time. That's the actual machine in the background. Now, one thing about the magnetic amplifier is it's also like the so-called alternator, is when you utilize this thing in an alternating current circuit harmonically, instead of with the DC control winding, again, the laws of conservation of energy no longer apply between the exchange between the two ports on the device. It can either create or destroy energy. Okay, that's what makes Alexanderson interesting. This is the first one that Marconi got, and then the Navy seized the whole situation. This was the beginning of being able to send a voice broadcast to Europe. This would be the New Brunswick machine. These are some of the towers they put up in New York to handle the antennas, but this type of antenna system that is published and known as the Alexanderson system is not the real system. The real system that he designed, you only find that full patent embodiment in Bolinas and New Brunswick. They're considered what you call a scalar antenna, in that there's no propagation velocity. It's instantaneous. The entire antenna operates in synchronism. So there's no wavelength or frequency to the antenna. It's completely neutralized. It's a concept that's not utilized in any other type of antenna. And the wires themselves are not radiating. There is no electromagnetic radiation. It's the roots that are buried in the ground that are doing all the transmitting. These massive underground copper electrodes are all buried in proportion along these towers. We'll see all that later. Okay, let's keep going. Okay, this is like a technical description of it and some other pictures. That's the basic schematic. is all the AC windings are all bused into or cabled into a parallel winding arrangement. So you have 64 coils. That way the skin effect and all these other complications are minimized. Wires of equal length, you weave it all, and then you have the pickup coil that steps it up to 2400 volts AC. This thing's operating at figure about 20 kilocycles a second, 200 kilowatts. So it's putting out at 2400 volts. It's still putting out quite a bit of current. This is the this is where the magnetic amplifier comes in to key it. So that breaks the magnetic circuit exchange between the primary and secondary. So this is the control coil in the transformer. Okay, let's keep going. This is the input, the motor that drives it. There's more magnetic amplifiers that are used here to regulate the motor speed. And then the antenna structure should actually be called, as I pointed out, the transmission structure. And then these are the shunt admittances that carry the transmission to the ground. It's all along here. Okay, let's keep going. This is one of the pickup transformers that mounts on top. It's a hot side here and a hot side here and a center tap, it looks like. And then the other windings you can't see, they're on the inside. Okay, keep going. That one's not too good. Okay, this is a New Brunswick antenna. This thing is about 5,000 feet, 5,000 feet. So it gives you an idea of what we're dealing with here. It's probably about 600-700 feet across. Use this type of tower structure where Bolinas used Marconi mass. This one uses the Alexanderson principle to the max in that there's no time delay. If the electricity, if the sine wave, so to speak, is at 0 degrees here, it's also at 0 degrees here. There's no time of propagation. It's all been neutralized. The thing operates completely out of any spatial dimensions. That's why it's called scalar, because there's no space vector. It's just a numerical quantity. It has nothing to do with the scalar of Tom Bearden or Art Bell or any of the disinformation agents. This is the actual mathematical definition of the word scalar. So I have to point that out because everybody here's mind has been infected by the disinformers to think that scalar means this communist Soviet technology of mind control, and we don't have any time for that here. This stuff's more powerful than that anyway. Okay, there's Alexanderson tuning his receiver. Keep going. Okay, this was his, like one of the celebrations. This guy lived to be real old, had several hundred patents. His last inventions were the high voltage DC system, like the big power line that goes into LA and all that. They're running at 1,000,000 volts DC right now. This guy helped develop the switching circuits and all that type of stuff. So this guy was an engineer from the spark gap day all the way up until integrated circuits. And then the ghost of Steinmetz is in the background. That was his mentor. He immigrated from Sweden as a college student all the way to America after Steinmetz wrote his AC book, which was the topic of the last discussion, and immediately threw himself in front of Steinmetz, and Steinmetz had to find him a job. So he got him a job drafting, and then, you know, they kicked him around for a while and whatever, and then Fessenden wanted this goofy alternator built that even Steinmetz wouldn't touch. So they gave it to Alexanderson as a joke, and it turned out to be one of the most important naval assets in the world at the time. Strange twist of fate for a Swedish immigrant boy to have all this experience. Okay, I think that's, this is when he first came to GE. You can see his pliers and Stilson wrench and, you know, hanging on, he's out there adjusting commutators or whatever he's doing, getting covered with carbon dust and transformer oil. That's how he began. Okay, keep going. This is one of his larger machines. The thing stands about 10, 12 feet high. Okay, keep going. That one's kind of hard to see. This one's, I might just have I've got a bad angle here too, don't I? Oh, okay. Yeah, you can see there's the motor. That motor is probably 7 or 8, this point here could be as much as 8 feet off the ground. One of them had a person standing in there, but I don't think we have that one. And then the alternator is a very strange contraption. And it has to have all this oil and cooling for the gearbox and water cooling for the windings. And this thing here is spinning at about 3,000 RPM. And for something with a radius like that, 3,000 RPM is quite a scream. So when they tested these things, they had to test them in blast bunkers. So if something did the big choke, you wouldn't get hit by, you know, pieces of flying stuff. There's kind of a closer view. You can see some of the gauges and what have you. The big eye hook on the top is almost a joke. God knows how much this thing weighs. Okay, and that's some of the antennas in Sweden that still operate. 15 minutes a year, but it's better than nothing. Okay, that's a coupling. Telegraph recorder. That's some kind of tube transmitter. That doesn't really relate. That's one of the towers from the bottom. I think the towers are 700 or 800 feet high or something like that, between 400 and 800. Here's one of the 10-foot high coils here. It's the building. Okay. None of this really much relates directly to Bolinas. Okay, here's a good shot of the machine. So you can see him standing by it, how big it is. He wasn't a little guy. It makes him look like one. Here's the Bolinas equipment that got moved to Hawaii during World War II for the Navy. So this was the alternator setup as it existed in Hawaii. This is the electrical generator for the power backup. These are the motor generators for exciting the DC windings in the machine. They're rectifiers, basically. There's the diesel engine again. Here's the main switchboard. Boy, it's a beauty. That's where all the power and what have you. There's the engine. There's the switchboard. There's more of the switchboard. Okay, here's the high-frequency transformers on the top, and these be the high-frequency leads out. And you can see this. There's the motor. You can see the variometer tuner. The magnetic amplifiers are on the other side. Here's the gearbox here. This side's running probably about 400 or 500 RPM, and this side's running in the vicinity of about 3,000 RPM. So this gearbox is cranking. Okay, these are some of the windings they used there, but they're not real Alexanderson coils. But it gives you an idea of the amount of inductance required. Things are massive. Okay, and that's the insulators they used in Hawaii. Give you an idea how they're built. They have these drip cones and stress cones so that the high frequency doesn't burn through the insulation, because the insulators, as we learned in the last talk, are actually where the electricity flows. So it burns them up. So they put the capacitors around them to keep the lines of force off the porcelain so it doesn't fry. And then the hood keeps the water from drooling down, which would cause a big blast. So these insulators have to be specially designed for this high voltage, high frequency service. So they act basically as what insulators are, capacitors without shorting out. Okay? Yeah, this is just some of their wiring. Let's keep going. Now, the reason why you do this is to keep the voltage gradient low. If you've got a skinny wire, then you've got a high curvature, and the fire tends to dance out off of it. So you have to have all these broad radius curvatures to deal with here. And then that also alleviates the skin effect. So when you have heavy circulating currents, then they don't lose them in your resistance loss. And then you can see the capacitance shields on the insulators here, but they're not on the top for some reason. Okay, let's keep going. Okay, now here's DeForest when he first came up with his Audion tube. This is what obsoleted the alternator, was the vacuum tube. DeForest never knew how to really make the thing amplify or whatever at the time. It was conceived of as a detector, and that's why he called it the Audion, because it made the incoming radio signal audible and provided a little bit of amplification, but otherwise it wasn't much more sensitive than the other radio devices at the time, until Armstrong and the phone company and various other people like General Electric and RCA and the Navy all came in and worked it into what it became. Okay, keep going. This is one of his stations. He'd throw these stations together, and then they'd operate them for a while, and then when the stocks would go out of business, then they'd just run. DeForest was heard saying when he set one of these things up, let's just wait and watch the suckers bite. So he wasn't really a clean operator. And of course he wrote books about himself too. So here's where it all came from was the Edison lamp, which had the what's called the thermionic emitter, which is the thing that lights up in the bulb, and this throws off what they called corpuscles, which now you might call electrons or ions, but back then they called them corpuscles. And Edison had a problem as these things were blackening the walls of his bulbs. So he put a metal plate in there to sample it, and I think that's in the next deal. Here's his tubes. He's got these little probes to see what this blackening stuff is, and then he found out of that he had created a type of diode. But he wasn't interested in that because his interest was he didn't want his light bulbs getting black. So one of Marconi's buddies named Fleming patented the diode action. Edison wasn't too much into patenting stuff. His idea was to make money, and then when the glommers came and wanted to take all your money in patent wars, invent something new. Made more sense to him. So Fleming patented it, and then De Forest figured out a way to make it into the controllable, what's called the thermionic vacuum tube today. This was the other radio system, which is a very strange system. It's a hydrogen cyclotron. It used to be known as the Federal Arc. And eventually, one of these devices became what's known as the Lorentz cyclotron, which was one of the first particle accelerators to use the rotating accelerating process to increase the electron voltage. Instead of just trying to get it in a straight shot, what you do is you just let the thing keep building up juice, running round and round in a circle, and then you get a big blast out of a small box. So this thing, originally what it did, it had a hydrogen plasma inside and a big arc. This thing the guy has his hands on is the big wheel to bring the arc rod in and out. And then you hook this thing to your giant coils and antenna system, and it went into oscillation. You put about 600 volts. These things ran off a railway current. So they 600 volt DC came in from the railway line. And then this plasma would act as a negative resistance to fire that would start, so to speak, in the hydrogen. And this giant magnet around the thing would force everything into this cyclotronic action. And this thing would go into an oscillation, kind of like a magnetron would, and produce extremely powerful alternating currents. And the biggest devices were 2 million watts. This one here is 1 megawatt. So the Navy decided at this point in wireless to go this route because these were the blasters. And they put out a pretty clean signal, unlike the disruptive discharge, or what they call the spark gap type, because it's more of an atomic process that's continuous and oscillating instead of this bang, 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 bang like the spark gap is. So there might even still be a few of these things around in operation. This was the original invention that spawned it. You dripped alcohol down in there, and then the plasma would form out of the alcohol and take the hydrogen and use that to perform this electrical discharge process.
25 minutes left.
Okay, let's keep going. Now this was Farnsworth's idea. So you have to remember now that this vacuum tube thing, RCA screwed it all up so that nobody could make or use or sell or buy or any vacuum tubes unless they had their mark on it, kind of like a biblical deal. So these guys all came up with their own ideas of tubes. So this is one that, that Farnsworth found would produce very powerful UHF oscillations that didn't really need a lot of circuitry or any of this type of stuff. And this was kind of the predecessor to what we call the magnetron. And then eventually he found that these things started producing their own electricity from what he called the, I forget the guy's name, he's a physicist. His name is either Dirac or Dirac. I can never pronounce those kind of names. But he had a theory, he called it the Dirac-C, where electrons came out of another dimension. And Farnsworth learned how to tap that. Okay, we'll keep going. So this is his public demonstration of this device. It appears to operate at 100% efficiency, which is pretty good for anything that lights up and has magnetic fields. Okay, and then after that, keep going. Oh no, go back. Okay, we don't see it yet, but he had come up with a way to do this where he would produce a sustained nuclear fusion reaction for a period of about 5 minutes. Where no one else was able to achieve this, he was able to do it with all vacuum tube or radio tube, television tube type technology. No giant magnets or lasers or any of these things at all. That picture was supposed to be in here, but we had to kind of economize.
It's on our website.
Yeah, so this is something that I rediscovered because the family crawled in their hole and were going to die with all this, but At any rate, as we shared our dumpstered food together, we got to learn things about each other. They didn't really get rich in the end off of this. They all died in misery. Okay, keep going. So back to Tesla. Tesla wrote a series of autobiographical articles about his ideas on radio during this whole historical period of what he had conceived and how he had learned his things and what he thought about was going now. And it could be a whole story in itself. So keep going through the Tesla. Okay, now this gets into the actual, this is what was built out there. So this is what the original Marconi antenna was made out of that he built, and the electrical characteristics of how it operated. So next page. So this is like how much capacitance the thing had. This is how much reactive energy. You can see this thing was operating at 150 megavolt amperes reactive. That's a lot of bouncing electricity. 44 kilocycles. That's why this thing lit up at night. It was basically it was almost like a nuclear bomb bouncing around in this thing. So this was part of the problem, is they had all this reactive energy, and it didn't contribute to the transmission process. The thing had no radiation resistance, so you couldn't use it to transmit electromagnetically. So the only thing you could try to do was transmit through the ground, and the overall efficiency of the operation was so pitiful that it hardly ever operated. But it took them a lot of years to build it, and it cost a lot of money, and at least started the site off with the structure that Alex Anderson could rework. So we have the total capacity. That capacity is bouncing this energy back into the inductance coils in the Marconi building. That's why those coils are so gigantic, because they're reciprocating this 150 megavolt amperes reactive. So most of the capacitance of the antenna is just to ground, shorted out between the 300-foot gap between the part in the air and the part in the ground. But there's a small part that goes out to the ionosphere. Okay, and there's 50 megavolt ampere reactives, or we'll call 50 megawatts associated with that. The energy required from the power company to do all this is 300 kilowatts. So it's using a resonant multiplication principle in order to get intense flows of power without any real amount of energy being involved. That's the Tesla principle. But it doesn't defy any laws of conservation of energy, because energy is being shuttled around in time. So there's no free energy coming out of this thing as far as your basic electrical calculations go. But that doesn't say that it's not doing some very strange things. Okay, keep going. So it would have been about 500 amperes. Okay, this is the energy consumed by the power company. The structure has a transmission impedance of 75 ohms, which is so low that it has no ability to radiate electromagnetically. Okay, Marconi chose the thing to be 1/8 wavelength long, so that the wave bouncing back from the structure at the end of the antenna would react with the wave going out from the powerhouse and cancel out a large portion of this reactive energy. So it was kind of an interference effect between the two waves to get it so that he didn't have this massive wave thundering all the way in and have to have the apparatus of the station absorb the whole thing. So if you take the two capacitances, you find out that the capacitance of the upper part and the capacitance of the part to ground gives a velocity of 1.5 times the velocity of light. Now this, of course, would irritate the Einsteiners. But according to the old wireless theories, is the free space wave would have to be 1.5 times the velocity of light, and the wave would not be electromagnetic, it would be electrostatic. So what was being used here has no resemblance to electromagnetic radio of today. This is operating in things that we've become accustomed to as impossible, but it's not impossible, because you just sit down and do the basic calculations out of any engineering textbook, and these are the answers you get. Okay, keep going. Okay, those were the books that I got the capacitance. So all the equations came out of regular books to figure out that stuff. So now we'll keep going. Okay, so this is how the structure was basically set up. There's the powerhouse, which is that giant building. And then you have these 300-foot high masts. So this is like 300 feet. This is 600 feet. And this goes out 3,000 feet. Thing's giant. And there's all these ground wires underneath the ground that follow it. I drew these in just to get the proportion. They weren't visible in the photograph. So this was Marconi's initial structure that he built there that Alex Anderson rebuilt. initially to get rid of this so-called reactive energy flow, but then other things grew out of the idea. Okay, so the next one. Okay, so this is what the antenna would have looked like lengthwise. This would be the building, and this would be the section up by the road. These are the masts here, and then there was 32 wires stretched between. Now, when I was a child, there were blueprints out there with Alexanderson's name on them, and it had structures like this, but that was a long time ago. So I'm trying to get an idea of how these masts would have held another type of structure that would have resembled that. So this is what you see going on here. So this is the original 44 kilocycle antenna. Okay, next. Okay, now if there were two rows, which would have been more likely, the antenna would have been strung like this, where these are the three masts. The evidence of this mast has been completely removed. There's no evidence anywhere of that mast's existence, but there's no way that that mast could not be there and this antenna hold itself together. And plus there's this row of masts here to carry down leads. And none of these things show up in any type of blueprints or books or anything that I've seen on any Marconi sites. So there's things going on in these stations that were kind of left out of the books. Okay, let's keep going. So this was Marconi's experiments and some professor's analysis of it. Marconi found with these antennas that they were directive in this direction. In other words, if this is the building and its networks and this is the transmission structure, that the propagation, as you can see by the field pattern, tends to go out in this direction. But the antenna is less than an eighth of a wavelength long. According to electromagnetic theory, it can't have a pattern like this. The pattern would have to be a perfect circle. So there's a mode of propagation going on with this disruptive discharge transmitter, which is not producing sine waves, but square waves. And this electrostatic transmission system, which is transmitting in a velocity, or as in the last talk, sometimes you don't even want to call it a velocity, but it's transmitting in another dimensional relationship other than the velocity of light. This was the calculated electrostatic field pattern, where this would be the antenna and the ground, and then the image antenna, the reflection off the ground wires, would produce this type of electrostatic field. And this is where this professor was reinforcing the idea of why this thing would propagate in that direction. So there's things going on with this old stuff that even though it didn't work like it was supposed to, or nobody really knew this or that, or everybody was fighting, or the government was taking over, it's these little things land out of it that is where the scientific interest lies, if there's going to be any other type of radio in order to overcome the barriers of distance and space. Okay, keep going.
15 minutes.
Okay, this is the antenna they built at Hawaii to reciprocate with the one in Bolinas. That'd be this one here. Here's the masts. This is the terminal thing at the end with the row of pipes. And then you have the building here. And they had another one to Japan. They could never get the system to work to Japan. There's something about the geology of the Earth will support no propagation to Japan. And that whole antenna thing was just, that's where Eppensheed in the beginning was joking about it to his buddy Harrod Pratt, that the thing never even worked. Okay, keep going. This is a view that Jim Bourne took when he was standing on one foot like Armstrong on top of one of the 300-foot masts. So, and then there's a picture, I think, next to him down on the bottom. That was him there. He was one of my, I don't know what you call it. These were the guys that took me in when I was a kid and got me all wrapped up in this stuff and made sure I had equipment and the papers are all in order and I had the keys or whatever, and I was the guy. A very fortunate circumstance for a 16-year-old. But I had help from the phone company and the high school, and I was a pit bull back then. I was like another Sarnoff. Okay, let's keep going. So this is kind of the overlay of where all the wiring had gone out there. This is like the road, about almost a mile up. This is the building down by the ocean. There's an auxiliary mast that held some other long wave antennas for KPH. Main call letters of the station were KET, and that would be the VLF station. So the Navy rebuilt the thing again in the war, and they just used a certain part, and they put an anchor in and terminated it here, and they never used the end section, and then just ripped the thing down, smashed the rest of it afterwards. But I managed to dig a lot of it out along the cliffs. Okay, keep going. This is part of the diagram I made of the system. These are like the anchors and the masts and the pad mounts for different things, and very complicated system out there. Lots of stuff buried in the ground. Underground antennas everywhere. And this whole structure out here is more than I can get into right now. Okay, keep going. This is one of the giant tuning coils. This one would be the parallel coil. Or no, the series coil. Yeah, this series coil. This is the one that connected element to element. Keep going. There's the shunt coil. That's the one that connects to the underground. Okay, these have to operate at very high voltages. They have lots of turns of big cable, 8 on each row, and then these porcelain things that, like they're insulators, but they're really bizarre that carried them out. Keep going. I think we got pictures of that. This is some of the setup. Rocky Point, similar shit, but not the, I'm sorry, similar stuff. Not the same. Not the same as Bolinas. This is the newer system that got modified. Okay, keep going. This is one of the insulators. The wires laid in these slots. So the 8 turns were held out, and this thing would be operating at about 100,000 volts. So you can see it took me 2 days to dig this thing. It was half implanted in concrete underneath one of these bases to get this thing out. The people that have taken over there have scattered all this stuff now, so it's all pretty much screwed up and gone. Okay, let's keep going. This is one of the original ship-to-shore KPH insulators. These are a bunch of insulators that I dug out of the ground that made up the sides of the Alexanderson antenna, and then there was some kind of special coil mount in here. I never did figure out what that connected to, but I did do some through-the-ground transmissions there. Okay, keep going. These are the mounts that the big coils sat on. Here's more of them here. This is where all the 3,000 foot of wires came down. This was the anchor that terminated them outside the building. This is a very complicated structure electrically and mechanically. Keep going. This is one of the ground studs that leads to underground antenna. Somebody goes out there and when I try to keep this stuff intact, smashes it up or does whatever they can to wreck it while I'm gone. So it's kind of hard to keep track of all this stuff. Okay, keep going. This is actually the point in which all the ground systems in the entire antenna field that have a metallic connection all come together at this point. This is right outside the Marconi building. It doesn't look like much. You can see everybody's half-baked additions afterwards. Like the Navy was very sloppy and didn't solder the connections when they wrapped their wires around here. And then some of these are original from Marconi, and some are from RCA, and some are from GE, and they all come together right here. So if you want to connect to the Earth, this is the place to do it. You can feel it when you put your hand on it. You can just feel it. So like certain days, like during solar flares or something's going on, you can just, this like tingling sensation in your body, like an excitement, but it's not always there. So we put a terminal on this and made like a little manhole that looks like a piece of junk on the ground, so we can always go back to it. Do experiments there with the PRC-74. Okay, keep going. There's more transformer mounts. It's all bare stuff now. There's the Navy's anchor where they dead-ended their short antenna. Okay. And I think that's it. Is it?
No.
No?
Shouldn't be.
Okay, this is the Alexanderson antenna calculations. They're more involved because the antenna is set up rather than just as a flat top. Now we have to deal with a waveguide. So this is the basic capacitance of the sections, and just like with the Marconi antenna, but this is much more complicated to figure out. Let's keep going. So again, it's the same number of lines of force, the amount of stored energy, the volt amperes. Okay, keep going. So this is kind of beyond most people here, but I'm going to put this stuff on the internet, so anybody wants to go back to this, they can. Okay, this is like my idea of how the rigging would have been done on this type of structure. This is the building here. Then you have the first 3 masts, and then the stringing of the antenna, all these very severe guys. This end capacitor that went to the terminations, which was an important part of Marconi's system. Okay, this is like the theory of operation of these antennas. I'm probably running out of time to really
10 minutes.
try to squeeze this in. This kind of gives you an idea of what's different about everybody's radio. So this is kind of the basic diagram of the Alexanderson antenna as it existed in Bolinas. Okay, next. This is one analog of it. This is how it would appear as circuit elements. In other words, from one set of mass to the next set of mass, this is what's going on as far as inductance and capacitance and current flow and current into the earth and space and all that type of stuff goes. Okay, this is the analog of the entire antenna. And these would be the reactances of each part of this antenna at the frequency at which it operated, which is 18.6 kilocycles. So this is, as you can see, it's a very complicated network. And to bring all this stuff into a situation where you can achieve resonance and scalar effects and all that type of stuff is not particularly easy, not alone to, having to invent it to begin with. To keep going. That's one of the coils. That's about how it would be laid out. These were the 8 turns, and that would give you enough inductance. And then there's wires that came up underneath the foundation and grounded this, and then the high voltage terminal. So this was the parallel coil. This is a 6-foot person would be standing right here. That's how big it is. Okay, next. That's the series coil. These turns were adjustable, high voltage on both sides, no ground wires in the bottom, so it came down, went in, and then went back out. So there was no ground connection at the series coils. Next. Okay, this is the various radio systems. If we start off with, first we have Hertz, okay, where you have 2 space radiators. But then you have Tesla, which is a transformer, which is earthed. So our radio today is this, and the initial radio of Tesla was this. Okay, so what Marconi did to get around the patent is he made the antenna Hertzian, but kept the transformer Tesla, the best he could within the realms of the patent. But that, through being at this terminal, is supposed to have a very high voltage and small capacity. This just dampened the whole system down, so it could never really perform the way it was supposed to. And you'd have all this stored reactive volt-amperes of megawatts bouncing around in your system. But this is how it went. And what Alexanderson did was this, where the antennas started to become just sections of transmission line, and then he had a system of transformers and multiple grounds. So that way you could get a broader bandwidth, and the current would be divided more between the grounds. Where the Tesla system was a single frequency, this could be broadened out and made more adaptable. So where this is an adulteration of Tesla's patent, this is an actual advancement of electrical science. Okay, finally, with RCA and Sarnoff, we were led into phase arrays of Hertzian radiators, and this is where radio is today. This is your cellular telephone antenna. So this is your basic radio progress. From this, let's go back. From the Hertz experiment, the Tesla transmission, and then the convoluted path it took into what Tesla would say was the wrong thing. But somebody makes lots of money off of it. Just like somebody said about Sarnoff, he took infant radio and taught it to pay. Okay, keep going. So these are how the various systems work. This is an electromagnetic antenna. Okay, the flux lines in one side of it are opposed to the flux lines on the other side of it, and are separated both in time. Okay, in other words, if this is on time, these flux lines are late, and these flux lines are early. So you got the magnetic crams in the middle, the electrostatic crams on the outside, so the two components of electricity are separated from each other in space. And there's a time factor involved, and there's a point right here where they unify into what you would call Plancks or photons, and then that creates the electromagnetic propagation, which is right angles to everything. So this would be your cellular telephone antenna. The little whip or whatever would be, this would be like one element of it. So there's this time lag. It's 180 degrees from side to side. It's consuming current into resistance, and thereby either receiving or transmitting energy out of I squared R and the frequency of what it's doing. Okay, keep going. Now this is the electrostatic antenna of Armstrong. Okay, the magnetic lines of force are all neutralized. The electrostatic lines of force are all of equal magnitude and in phase. So as you go down the antenna, everything is operating on time. So the whole antenna is operating as a unit, where the way Marconi operated it is you get these standing waves and lags and reactive power flow. So this is a whole different way of transmitting. The magnetic field in this is virtually non-existent. The electrostatic field is in operation. And any place where electromagnetism is generated in the crossings, there's another one out of phase next to it, so it's a canceling process to leave you with an electrostatic field. It's a very interesting way to transmit electrostatically and get around the Tesla patent. But leave it to Steinmetz and Alexanderson.
So this is Alexanderson, not Armstrong, right?
Not Armstrong, no. Okay. Next. So basic principles of operation of VLF is you have the space outside the Earth, which conducts electricity as a rarefied plasma or gas. You have the space inside the Earth that, to use the word conduct is difficult, but at any rate, we can say they're conducting. The inside of the Earth conducts because of the ions in the mineral and the water and all the ionic process. This does it by all the, atoms that are hungry for electrons or have too many or all that type of world. So this is all working in the plasma world. This is all working in the electrochemical world. But at any rate, they both can be considered plates of a capacitor. In between, you have a so-called non-conducting atmosphere. So we are standing inside this giant high voltage capacitor which consists of the ionosphere and the physical Earth, and the atmosphere is like, the glass plate or the oil or whatever would be in between in the capacitor. Now the Tesla system, the way it operates is the space current and the ground current have such a phase relationship that it doesn't want to run around in circles. So it has the ability to transmit longitudinally with no velocity restraints in the space, and it has the ability to transmit longitudinally into the Earth with no velocity components. The Marconi system and the system of Alexanderson is like halfway in between, and the radio we have today is like this. The Marconi system is the phase is such that all the lines of force return back around to where they came from and form closed loops. So any transmission has to be electromagnetically, and it's not electromagnetic structure, so it tends to be self-defeating. So this is kind of how that antenna in Bolinas would operate with Tesla, and Alexanderson would be more like this, and Marconi would be like this. Okay, keep going. So in the Tesla system, the Earth connection and the space connection operate 90 degrees out of phase. So they're never, when one's hot, the other one is not active. So you have a separation of the two poles. They're no longer plus and minus. Plus and minus is gone. There is no plus and minus. There's either a plus here or a plus here at different points in time, or a minus here and a minus here at different points in time, but there's no plus and minus. There's no way that the flux can loop, because when this one's on, this one's off. The Marconi system and conventional AM broadcasting and stuff today operates with the two 180 degrees out of phase. So when this one's plus, this one's minus, and when this one's plus, this one's minus. So the lines of force all tend to go back around, and the propagation tends to become self-defeating. Okay, keep going. This is the basic schematic of the Alexanderson system as far as the layout of the elements and where the coils sat. Keep going. Okay, this is the scale model that the ham radio people can build for 160 meters if they want to experiment with this. A 100-to-1 scale model gives you a frequency of 1860 kilocycles, which is in the 160-meter ham band. So this is the diagram, the plan for this. These would be the coil positions. This would correspond to the wires between the masts, and then you'd have the underground wires. The capacitors and coils on the ground and their down leads. Instead of being 300 feet high, of course it's only 3 feet high because it's 100 to 1. Because of the inductances and capacitances, the fields operate on square roots. They're 1/10 the size. So the square root of 100 for the coils and capacitors, otherwise they'd be so tiny and the energy balances wouldn't work out. So the way the waves split is because the two forces are multiplied by each other. These things move in square root proportion. So that's all been done. Okay, keep going. This is the various other sections of the antenna. Keep going. That's what it looks like from the top. That's the upper structure made out of copper wires. The next row down is the copper pipes for the grounds, which are these, and the rods that go into the ground, and then the mounts for the coils and capacitors. Keep going. And then, this is the guy that had all the equipment smashed out there. And then we got a couple other guys here. This is all the stuff that they've managed to bust up while they were there. They destroyed almost all the equipment and dumped all the toxics over the cliff. And then they turn out to be new age cancer research. These are the Greenpeace guys that have control of the station now. And they're yanking stuff out of there and selling it off, and closed it to everybody, and are trying to make it like Alexanderson, and none of these people ever even existed out there. But somehow they gained control of the whole facility, And the place is a circus now. So here you have a prime naval asset is a circus, just like the people that ripped the Navy off in the beginning. So that's the end of the talk. Well, I guess, what do we want to do next?
Say something about the website?
That's you got to say about that.
Okay.
I live in my car.
You can,